Question 1. When one or more hydrogen atom of an aromatic hydrocarbon are replaced by corresponding number of halogen atoms, the resulting compounds are called as A. Halogen derivatives of alkanes, B. Halogen derivatives of alkenes, C. Halogen derivatives of alkynes, D. Halogen derivatives of arenes. So over here we'll first make any arene. Arene is my cyclic hydrocarbon. Let's say this is benzene. And over here, one hydrogen is replaced by any halogen. Halogen can be anything: fluorine, bromine, chlorine, iodine. But mostly these three are being used as this is very reactive. So if one hydrogen is replaced by an halogen, this will be a derivative of an arene. So option D, halogen derivative of arene, is the correct answer. Question 2. Alkyl halides are used as A. refrigerants, B. dry cleaning agents, C. insecticides, D. all of these. So alkyl halides, alkyl halide, alkyl means a carbon chain in which the hydrogen of any of these carbons, either this or this, is replaced by an halogen. Halogen is X, fluorine, bromine, chlorine, iodine, anything. So the uses, when you see the uses of this, they can be used as refrigerators, dry cleaning agents, and insecticides, all of these. Therefore option D, all of these, is the correct answer. Question 3. Tert butyl bromide can be written as. So when I have tert butyl bromide, first I'll draw what is tert butyl bromide. So this is my carbon chain. This is my tertiary carbon because it is attached to all three other carbons. And I will have a bromide over here which is attached to a tertiary carbon. All these carbons have been attached to hydrogens. So this is the molecular formula, or this is the structural formula of my tert butyl bromide. So now when you write the molecular formula, this is 3 times, that is CH3 is 3 times, 1, 2, 3, CH3 twice, then I have a C which is attached to a Br, CH3 CBr. Option A is CH3 CBr. Therefore option A is my correct answer. Question 4. Chlorination of alkanes takes place in the presence of A. infrared light, B. diffused sunlight, C. alpha rays, D. beta rays. Chlorination of an alkane in direct sunlight can be explosive. It is done in the presence of diffused sunlight or UV light at high temperature. So when it comes in the contact of direct sunlight, it will be explosive. So here we use diffused sunlight. Diffused sunlight is not that strong and thus it won't get explosive. Therefore option B, diffused sunlight, is the correct answer. Question 5. In anti-Markovnikov's addition of HBr takes place in presence of. So in anti-Markovnikov's rule, we had the halogen attached to the most saturated carbon, but in the anti-Markovnikov's rule, the halogen will be attached to the unsaturated carbon, and all of this happens in presence of H2O2. Therefore option C, H2O2, is my correct answer. Question 6. Ethyl alcohol on treating with thionyl chloride gives off which gas? A. Cl2, B. C2H6, C. SO3, D. SO2. So over here we'll first write the formula. Ethyl alcohol This is my ethyl alcohol, 2 carbons attached with an alcohol, plus thionyl chloride. Thionyl chloride is SOCl2. When I will have it with pyridine, it will give me C2H5Cl plus HCl, that is a gas, plus SO2, that is a gas. This is the purest form of ethyl chloride. So over here it gives off the gas SO2 as a byproduct. Therefore option D, SO2, is the correct answer. Question 7. Which of the following compounds has an offensive order? A R-NC, B R-CN, C R-O-Na, C R-O-R-. So alkyl isocyanides is this R-NC, generally possesses a bad order as an offensive order. Therefore option A is the correct answer. Question 8. Methyl bromide on reacting with silver acetate gives A. Acetic acid, B. Acetyl chloride, C. Methyl acetate, D. Acetaldehyde. So over here we'll first write down methyl bromide on reacting with silver acetate. Methyl bromide is CH3Br plus silver acetate. Silver acetate is CH3COOAg. So on heating this, when you heat this, on heating it, you will get as CH3COO, and instead of Ag, you will have CH3 plus AgBr. This is nothing but my methyl acetate. So the reaction will be forming methyl acetate. So methyl acetate is option C. Option C is the correct answer. Question 9. The property of virtue of which a compound can rotate the plate of polarization of light is known as A. Photolysis, B. Photoscience, C. Optical activity, D. Polarization. The answer is option C. Optical activity. Question 10. The reactivity of various types of alkyl halides towards SN1 reaction is A. Primary greater than secondary greater than tertiary, B. Secondary greater than primary greater than tertiary, C. Tertiary greater than secondary greater than primary, D. Secondary greater than tertiary greater than primary. So the reactivity is directly related to the rates of formation of carbocations. So any reactivity related to the alkyl halides is directly proportional to the rates of formation of carbocations. So now rates of formation of carbocations is obviously tertiary greater than secondary greater than primary, and that is again greater than my methane or the methyl group. Over here the option is C, tertiary greater than secondary greater than primary. Option C is the correct answer. Question 11. Aromatic compounds have A. Pleasant smell, B. Unpleasant smell, C. No smell, D. Smell of rotten eggs. Aromatic compounds are named aromatic because they have a pleasant smell. The name itself contains aroma. Aroma means something which smells good. Many of these aromatic compounds have been used to give smells to various food products as well as perfumes. It gives a smooth, fleshy, fruity smell or a flowery smell. Therefore, option A, pleasant smell, is the correct answer. Question 12. Which of the following is an aryl halide? So over here, this option D will be ruled out on its own. It's not an aryl halide because there is no halide in it. There is no halogen in it. Option B is again ruled out because it's a cyclic alkane and not an aryl. Aryl is an aromatic compound. It does not have any double bonds or pi bonds in it. Therefore, option B is again ruled out. So we have option A and option C. Over here, this halogen is attached to the compound, but it is not directly attached to the carbon which is attached to the ring. Therefore, it won't be. And this is my correct answer. This is my aryl halide, as the halogen is directly attached to the carbon which is attached to the benzene ring. Option C is the correct answer. Question 13. The weakest C-Cl bond present is A, B, C, D. Over here we have four options, but the weakest bond will be in option D. It is because due to the double bond character of the CX bond in an aryl halide, the CX bond is shorter and stronger. But in the structure D, the Cl is not attached to the benzyl group. So over here it is directly attached to the ring, and there is a double bond present over here, due to which it is shorter and stronger. Over here and over here it is directly attached to the ring, but in this case there is another C and it is attached over there. Therefore option D is the correct option. The CCl bond in the chlorobenzene as a compound with CCl bond in methyl chloride is A longer and weaker, B shorter and weaker, C shorter and stronger, D longer and stronger. So over here, let us first draw methyl benzene and chlorobenzene. Okay, so this is my chlorobenzene with my Cl bond, chlorobenzene. And this is my methyl benzene, that is my CCl bond. So now over here, if you see, in the chlorobenzene, it has double bonds. These are my pi bonds that will resonate around the entire benzene, the entire circular chain of carbons. And over here, I have only one long bond of C and Cn. So over here, due to this resonance, this bond becomes stronger. And since it is a stronger bond, it will come closer and it will get shorter than this bond, which is my longer and weaker bond. So the chlorobenzene bond will be shorter as well as stronger as compared to my methyl chloride. Therefore, option C, shorter and stronger, is the correct answer. Question 15. In aryl halide, halogen atom is attached to A. Carbon atom of benzene ring, B. To the carbon atom of side chain, C. Both benzene ring and side chain, D. None of these. So first let us draw an aryl halide. Let's say this is my chlorobenzene. So when I draw it with my carbons, and over here, this is my halogen. So this halogen atom is attached to the carbon of my benzene ring. Therefore, in aryl halide, halogen atoms will always be attached to the carbon of the benzene ring. Option A is my correct answer. Question 16. Aryl halides undergo A. Wurtz fitting reaction, B. Friedel-Crafts reaction, C. Sulfonation, D. All of these. Aryl halides have all the A, B and C reactions. Therefore, D. All of the reactions mentioned above is the correct answer. Question 17. If two halogen atoms are attached to the same carbon of an alkane, it is called as A. Alkyl halide, B. Alkylene halide, C. Alkyl diene halide and D. Aryl halide. So over here, let's assume that we have a butane. I've made the carbon chain eliminating the hydrogens because over here we concentrate on the carbon chain. And let's say I have two halogens attached to the same carbon. So this structure comes under alkyl diene halide. Therefore option C is my correct answer. Question 18. Ethyl chloride reacts with sodium in dry ether to form butane. This reaction is named as A. Rosenman reaction, B. Fitting, C. Wurtz, D. Clemenson's. I have my ethyl chloride. It will react with sodium in presence of dry ether and it will form butane. This entire reaction is known as Wurtz reaction. Option C is my correct answer. Question 19. The method of separation of racemic mixture into dextro and levo isomers is known as A. Asymmetric synthesis, B. Dissolution, D. racemization, D. Polarization. Option B is the correct option, resolution. Question 20. Which of the following is used to measure optical activity? A. Chemical tests, B. Polarization, D. Spectroscope, D. Potentiometer. Option B, polarization, is my correct answer. Question 21. Inductive effect does not operate in A. HF, B. F2, C. CH3Ci, D. CH3COOH. So for inductive effect to not apply, there should be no electronegativity difference between it. So if I have F2, the amount of electronegative this F will have, the same amount of electronegativity this F will also have. So when I talk about the electronegativity difference, that is the difference between the electronegativity of these two, it will boil down to 0. And if there is no difference of electronegativity, there will be no inductive effect. Therefore, option B, F2 is my correct answer. Question 22. Halogen derivatives of alkanes are classified according to A. Nature of halogen group present in the molecule, B. The number of halogen atoms in the molecule, C. The number of pi bonds in the molecule, D. The number of carbon atoms in the molecule. So over here, when I have to classify halogen derivatives, I will classify as mono halogen derivatives, dihalogen derivatives, tri halogen derivatives, tetra halogen derivatives, or poly halogen derivatives. Monohalogen means in my entire carbon chain there is only one halogen which is attached to it. Di means there are two halogens attached to it. Tri means there are a minimum of 3 halogens attached to it. Tetra means 4, and poly means more than 4, or n number of halogens attached to it. So the number of halogens in the molecule matter for the derivative, for halogen derivative classification. Therefore, option B is my correct answer. Question 23. Haloforms are trihalogen derivatives of C2H6, BCH4, DC3H8, DC2H4. The trihalogen derivative will be of CH4, wherein all the 3 H's will be replaced by an halogen, that is 3 times halogen, that is all the 3 H's are replaced by 3 different halogens, or one halogen. Let's say this is CH4. So either all these 3 can be replaced by 3 different halogens or by a same halogen, but they are derivatives of CH4. Option B is my correct answer. Question 24. Which of the following is a secondary alkyl halide? A. Isopropyl chloride, B. Isobutyl chloride, C. N-propyl chloride, D. N-butyl chloride. When you talk about secondary alkyl halides, you cannot have N-propyl chloride and N-butyl chloride. It is because if we see option C, it is N-propyl chloride. The chlorine is attached to the primary carbon. Even in option D, it is N-butyl chloride. So both option C as well as option D cannot be. When we talk about isobutyl chloride, it is my isobutyl chloride. Again, this carbon to which it is attached is a primary carbon. The only option left is isopropyl chloride. This is my isopropyl and this is my chloride which is attached to it. And over here, this carbon is my secondary carbon. Therefore, option A, isopropyl chloride, is my correct answer. Question 25. IUPAC name of this compound is A. 3-bromo-3-methylhexane, B. 3-bromo-2-ethylpentane, C. 2-ethyl-3-bromopentane, D. 2-bromo-3-ethylpentane. So over here, first let me write down this in the carbon chain form. So I have C2, I made C2. Again I have a C over here. Then this C is being attached to a Br. This is my C, and over here again I have C2, so this will come down. I have written the same thing, eliminating the hydrogens and then showing the bromine attached to the carbon. This makes a clearer vision of the given structure formula. Over here, first let's find out the longest chain. 1, 2, 3, 4, 5. This is 5, and 1, 2, 3, 4, 5, 6. So this is my longest chain. I'll mark my longest chain. After marking my longest chain, we'll do the shortest number rule, which will be my shortest number. So counting from here, it is 1, 2, 3, and counting from here, it's 1, 2, 3, 4. The smallest number is 3, so we count from here 1, 2, 3. So 3. So this will be my 3-bromo, 3-methyl, and 1, 2, 3, 4, 5, 6 hexane, because 6 is an hexane. So 3-bromo, 3-methyl hexane. Option A is my 3-bromo 3-methyl hexane. Therefore, option A is my correct answer. Question 26. Isobutyl chloride in IUPAC name is named as A. 1-chloro-2-methyl-butane, B. 1-chloro-2-methyl-propane, C. 2-chlorobutane, D. 2-chloro-2-methyl-propane. So, where first we will make isobutyl chloride. Isobutyl chloride. This is my isobutyl chloride. I have made the structure formula eliminating the hydrogens. Now over here we'll first find out the longest chain. This 1, 2, 3 is my longest chain. You can even take this as the longest chain because even that is equal, that is 3. Now we'll apply the shortest number rule. This is 1, this is 2. So it will be 1 chloro, 2 methyl propane. 1 chloro, 2 methyl propane. Option A is my correct answer. Question 27. The general molecular formula of alkyl halides is AR-X-R, BCnH2nX2, BCnH2nX, DCnH2n plus 1X. Now let's take an example to solve this. This is my ethyl chloride. This will be attached to 3 hydrogens because there's one carbon over here, and this will be attached to 2 hydrogens, and other 2 is a carbon and a chlorine. Now when you calculate, this is C2, H1 2 3 4 5, and this is Cl. So this will be Cn H2n plus 1, 2 into 2, 4 plus 1, 5, and X. Option D, Cn H2n plus 1X is my correct answer. Question 28. The reaction of ammonia with methyl chloride in presence of alcoholic KOH is called as A. Ammonolysis, B. Hydrolysis, C. Isocyanide, D. Words. Of course, the reaction contains ammonia. Therefore, the answer is ammonolysis. Option A is my correct answer. Question 29. To get alkyl isocyanide from alkyl halide, the latter is heated with A. aqueous KCN, B. AgCN, C. alcoholic KCN, D. all of these. The answer is AgCN. Option B is my correct answer. Question 30. When C2H5Br is treated with excess amount of alcoholic NH3, the major product obtained is A. ethylamine, B. diethylamine, C. triethylamine, D. tetraethyl ammonium bromide. So over here, let's first write this C2H5Br. This is nothing but my ethyl bromide plus excess amount of alcoholic NH3, excess alcoholic ammonia. So when you heat it under some pressure, you will get as this NH3 will break down to NH2 plus H. This NH2 will come here, and plus this H will go with this Br and form HBr. This is nothing but my ethylamine. Option A, ethylamine, is my correct answer.